Okay. Um, okay, I spent like 5 more minutes, so hopefully I will have enough time for that. So I guess you can see my screen, right? So okay, good. So I'll just talk about like a little bit this Shannon's secrecy idea. Shannon's secrecy. Uh, so it's something about like cryptography, like um, not exactly like how to build cryptographic system, uh, but it's like the theoretic, like other aspect, like in information theory, we are looking into like what are the theoretical limits, like for all these problems. So let's consider like a very simple setup. Like we have some messages and we want to transfer, I mean, transfer like from maybe Alice to Bob or something like, and that maybe like some if like it would be eavesdropping like for that. So we want to encrypt that. So to encrypt that, then I have this message right from Alice. I was first encrypted into some kind of cipher text that called C here. And then like the cipher text, like, okay, and I will also use a key for that, like use a key to encrypt this message. And then I will transfer the cipher text. And we have a symmetric cryptographic setup. So I will assume that the receiver, like let's say Bob here, this Bob Alice, Bob here will also have the key. So then he received the cipher text, it will able to recover the original message. So this message should be the same as this message. As M had is the same as M here. So the very interesting result by Shannon is that like, okay, this is I guess this setup is it shouldn't be. Oh, if I oh okay, like I hope I answered like Sarah's question. Yeah. So the canvas like for the review there, you basically just have the order according to, yeah, the order will be according to the actual orders. I will change the order in the schedule, but the presentation next week will be considered the presentation today, but the fifth presentation. So I hope it's clear. So I would like to create another assignment earlier, but then I realized like because some of you guys will see like once you start working on that, like you won't see the change. So that would be like I will have two versions. So therefore it's better to just keep the original one. Yeah. You can feel a little bit of that. Like yeah, you can feel in some of that, and I don't know whether you can save it. Oh, like you can, yeah, that is tricky. Like maybe I'm sorry about that. Like maybe you write it on a paper first, like what or like put in a file and then put it in later. I'm not sure they have a save. Yeah, I don't think it has a save function there. Like I don't know. Like I don't know whether you can save it before. Yeah. So yeah, okay, but yeah, thank you. So now back to this Shannon secrecy. So the Shannon's result is that like something is rather surprising. So you're thinking, okay, I'm going to encrypt it. Okay, okay, to encrypt this message here, and then like I need to use some kind of keys, right? So for example, like you know like on the internet, say you always hear like different kind of like length of keys with 256 bits or like uh 1024 bits and so on. Uh, but for Shannon, he realized that like if you really want to have perfect secrecy in the sense like yeah, I will explain later on. Uh, then the length of the key or like the entropy of the key will be essentially have the size at least the length of the message. I mean, the amount of information of the key has to kind of like has as much information as the message itself. So it seems like a pessimistic result, But this is only when you really have perfect secrecy. So if you want to have perfect secrecy, then you will ended up have this. So let's see, like, what do we mean by perfect secrecy? So now I have this message key and the code ciphertext here. We will assume this operation is deterministic. I mean, for both the encryption and decryption. So therefore, like C is just a function of the message and the key, right? So it's a deterministic function of this message and the key. And also like decryption as well. Like this M hat is a deterministic in terms of C and the key here. And so because like there's no ambiguity here, so I should have like the message given the ciphertext and and the key should be equal to 0, because I now if I have like the ciphertext and the key, and if I look at like the entropy here, of course like this is deterministic. First I will have like this is equal to 0 because m hat is just a function of like CMK here. Now because m has also equal to m, so therefore I have like hm is given CMK is just 0. So that's obvious. Um, and also, um, I should have like I should assume CMM to be independent. I should assume like CMM into independent. Because if they depend on one another, like that's the things like about perfect secrecy. So any dependency between them, that potentially you can leverage this shared information um, to undermine the ciphertext to collect the message itself. So therefore, like to have perfect secrecy, that's our assumption. Like what do we mean by perfect secrecy? If we want to have perfect secrecy, CMM should be independent. So is that clear? Basically, we have like two assumptions here, one and two here. This is related to perfect secrecy. CMM just independent, and because everything the encryption and decryption is deterministic, so like this conditional entropy, m given ck is equal to 0. Now from these two, we should be able to derive this. So let's see. Um, uh, First, like we see that like because of the independence here, so that means that like these two are independent. What do I have? Like I have essentially, I mean first way like ICM is equal to 0, right? They are independent, but also it means that like ICM is like just HM minus H M given C, right? So this equal to 0, or I have like HM is equal to HM given C. So then, and we also like this is like one result here. Maybe I just say this is a one. This is like kind of obvious. This is just coming from this perfect secrecy here. If perfect secrecy, I will have that. Like actually, you can directly see in that CMM independent. I should have HM is equal to HM given C. Yeah, that yeah yeah. Um and let's see. And also like know that we will have something that HM given C will be less than equal to HK given C. So I'm actually if if this is a this step, if we prove that, then we are already done because like HK given C is less than equal to HK, right? This is a this is basically is a conditioning reduces entropy, right? So when you condition, your entropy always reduces. And then like this, because of this step here, like this will be equal to HM. So then we are done. We have like this kind of result from Shannon, say the condition from Shannon that we need the key has to be at least the size of the message itself when we want to have perfect secrecy. Now we just need to show this one. So note that hm given c, let's see, hm given c, of course, it's less than h. Let me write a little bit better. Hm k given c, and so this is because this is equal to hm given c plus hk given mc, right? And of course, all this conditional entropy is positive, so therefore, like because all the variables here is discrete, so it's like positive, right? So I have this is bigger than that. But on the other hand, this is I can kind of decompose in another way. Hk given c plus hm given kc. Now we mentioned earlier that like because this is this condition here, because everything is deterministic, and also the decrypted message should be the same as the original message. I have hm given kc is equal to 0. So therefore, like, yeah, we are done essentially, right? I have hm given c is at less than equal hk given c. So yeah, I guess that's it. Uh pretty quick. I'm not sure because I think like if I ask you guys some questions, like to pause and then you can absorb a bit better. But like because we are running out of time, so mm, yeah, I guess if you but the derivation is all very simple. It's like I just take this as an example like of usage for information theory idea. You see, like for the information measures that we knew, like simply those entropy, conditional entropy, and also idea of independence and so on. You can derive something pretty counterintuitive like this. I guess at the first in the beginning, like it's not apparent to anyone. Essentially, again, like when you when you um, want to have a guarantee that like your ciphertext to be like independent with your message, and still you're able to recover the message losslessly uh, after encryption and decryption, then the consequence, like immediate consequence, would be like the size of the key, or like the amount of information of the key would be at least the amount of information of the message itself. So that's it. So I guess uh, I will talk a little bit communications, channel coding next time. Um, and actually, yeah. And if you guys have any, and some of you still haven't submitted homeworks yet. I mean, all the previous homeworks. So I can't talk about homeworks in class unless all of you guys submitted the homework. Um, I think like what um and by the way, like uh I guess I will agree that like the class after next class will be the midterm. So yeah, time flies. So I guess what I will do is I maybe if not all of you have submitted the homework, I will just uh send out solutions to those like, who already submitted the homework. And then if you have any questions, like individual questions, just shoot me like emails, not emails, shoot me like messages through Discord. That's the best. Please like use Discord as much as possible because email, especially when you have a list of questions, um it's quite annoying to take back like what we have. You know, like that's chain of emails, need to go back and back and back. But on Discord, like when we have this discussion, it's very easy to see like what we just discussed. So it's actually easier. So any questions, comment, concern? So if not, I will just stop now. And remember that you guys have another assignment due this week also. So for the midterm, I guess we will cover more or less all these assignments and some of the basically questions and also like the quiz like we discuss in class. Uh, it may cover a little bit of the channel coding. I for that part will make it simpler if I ever put a question for that one. Um, yeah, we can talk more about the midterm like uh, next time, I guess. So I will just stop here now. Like if no one have any questions and comments. Uh, let's see. But let's see. Homework fee delay a bit, but then like let's see. Uh, uh, I guess the midterm is good for to be still like November 10. Um. Uh. So. Uh. Let's see. Today. I mean like the I guess I can defer couple days. Yeah, that's possible. If you want to delay until say, uh, once I guess I maybe like Tuesday night, maybe better. How about I put it like the new due date is Tuesday night? So because I know like I'm that kind of okay, maybe you guys are not. I'm those kind of people need pushing a bit. So so and I think like it's better to have the homework like you went through the homework a class before the midterm because I definitely the midterm will cover like the homework. So yeah. So okay, I will move the due date to next Tuesday then. Yeah. So okay. So okay. Okay. Talk to you guys then. Yeah. Bye now.